Okay, gentlemen, good morning. April 1 and almost 10. We start our class. We'll practice today with rational expressions. See how it looks. So simplify rational expressions. We had something like that before. So let's have a look what it is now. So if I take 12 over 15. So what's the idea here? Idea is to find common multipliers and divide both numerator and denominator, right? In this case, what we can do, 3. So if I divide, it's 4 over 5, right? So B, 24 over 36. Well, if I take 6, right, what I have, 4 over 6. What else I can take? 2, 2 over 3. So in general, 12, right? 12. So it's okay if you don't see right away. Nobody will die because of that, right? It just will take you a step or 2 steps extra, right? So C, 2x squared yz cubed, 4x y squared z. So in this case, we first let's work with numbers. Let me take my red pen. So what is it? 1 and 2. Now for the x's, here I have x squared, here I have x, so I have left x here. Y squared, z squared. Good. So as a result, I have x z squared, and here 2y. Is it? Looks like it is. So D, 9a squared b cubed 3ab. So what I have, 3 and 9. So what happens to the fraction? It disappears, right? So something over 1, I can write that just as a number, and I have 3ab squared. Good. Let's write this one. Okay, so 15 over 35. What is that, 5 probably? So 3 over 7. The second one, 3x y squared z, 9x squared yz. So x, 3x disappears. I have z here, sorry, y. Now at the bottom, I have 3x. That's it. Right? So make it beautiful, y over 3x. Is it? Looks like it. Okay, 3, 12a cubed b, 4ab. So 4ab disappears here. I have 3a squared. Good? Okay. Simplify the rational expressions that are already in factored form. So let's start with a. X plus 2, x plus 2, x plus 3. So what happens here? I see x plus 2 and x plus 2. The only thing we have to say that x is not equal minus 2. Otherwise, we will divide on 0 and this. For all other x's, it's good. Any questions? Asra, did you get these restrictions here? Okay, here, this one b, 3ab, a plus 4, 6ab, a plus 3. So what I have, AB and AB, 3 and 6, so I have a plus 4. At the bottom, I have 2, a plus 3. And again, well, probably here we don't have to talk about that restrictions, but it's a good thing to understand that they are there, right? And a not equals minus 3. So what, by writing these restrictions, we're making sure that denominator is not 0, right? Okay, so C, 2x squared, 2x minus 1, x cubed, x minus 1. So what I see here, x squared, x cubed, so 2x minus 1, x minus 1. That's only thing what I can do here. And x not 0, x not 1. The last one, x plus 3, x minus 4, x minus 3, x plus 4. Nothing. So x. We cannot simplify that at all. Right? Any questions? Try this one. Okay. So what do we have? 5, 2x minus 3. So entire 2x minus 3. What I have, x is not minus 3, right? Okay, the second one. So just that, right? By y. So x here, not 0. X here, not 2. Third one. Well, there is nothing to simplify here. So x not minus 2 and x not 3. That's it. Any questions so far? So to simplify rational expressions, we factor completely both numerator and denominator, reduce factor common to both the numerator and denominator, write the simplified expression in either factored or expanded form. Basically what we did. That's just the algorithm, right? So reduce each rational expression to its simplest form. As you see now, it's not factored. So what we have to do, we have to factor it first, and if it's possible, reduce, right? So numerator here, nothing we can do about it. In denominator, we can take 4x outside of the brackets, and I have x plus y, right? So what I see. We're not going to write restrictions now, right? It's not something what we concentrate about. The restriction is x doesn't equal to y and negative y, and x is not 0, right? So typically restrictions, that those values what makes this uh, impossible. That's it. So as a result, that's what I have. So a squared plus b squared, a squared minus b squared. Even if I expand the bottom, I mean, if I factor the bottom, it's not going to change anything, right? Because what? Numerator, it is what it is. So probably simplest form would be the original form, right? Do I have a page? No, I don't. Okay. C. So x squared minus 6x plus 9 x squared minus 9. So this one, let's practice that what we learned last time, right? So here on a side, what I need, 1 times 9, no. Uh, 2 doesn't work, 3 times 3, yes, right? So minus 3 minus 3x plus 9. And here I have x minus 3, oops, minus 3, x minus 3, and x minus 3, x minus 3. That's one thing. Another thing, I can say that here is 3 squared, and 2x times 3 is 6, right? So I could go right away and put x minus 3 squared here. This what I have, x minus 3, x plus 3. So 1x minus 3 simplifies, disappear, and I have that. Okay? So guys, as you see, either or this method, probably we should start with analyzing the free element. Is it the perfect square, right? Aiming for that formula. Well, so D, 3x squared minus 12, 6x plus 12. What I can do here, I can take 3 outside, x squared minus 4. Here I can take 6 outside, and I have what? Oops. X plus 4, x plus 2, right? So at the moment, that's the only thing I can simplify. Now x squared minus 4, I can expand or factor as this. Good? If you have any objections, let me know. So let's do this way, 1 over 2, x minus 2. Okay, so E, A minus B, B minus A. Well, either or, let's say A minus B, I leave as is. Here I take minus outside, and I have minus 1. Good? Okay. Try this too. Oh, 3. Oh, actually 4. Okay, try this 4. Anyways, let's work with that thing. So x minus y, 3x squared minus 3xy. At the top, it is what it is. Here I can take 3x outside, right? So as a result of that manipulation, I have this. Okay, sometimes this. So second, okay. Oh, wow, what was it? Okay. What I see here, 4 and 4, and I can use formula at the bottom, but it's not gonna change me anything. Only just the practice thing. But probably the most simplest form would be still this. Right? That's what I think. That's my personal opinion. Okay, 3. Okay, let's check this one for the perfect square. It's 4 squared, right? 4 times 2, 8 times x. So at the top I have x minus 4 squared. Here, 16 is 4 squared, so x minus 4, x plus 4. Now what I do, this and that I simplify. Good. 2x minus 5, 5 minus 2x. Well, the same thing. Let's take minus from the outside in the numerator. And I have minus 1. Sometimes people put 0, but it's not, right? It's minus 1. I mean 1, but minus because of that. Okay, so next step, we will multiply and divide rational expressions. Here's the algorithm. Convert any division to an equivalent multiplication. Factor completely every numerator and denominator. Reduce factor that are common to numerator and denominator. Multiply remaining factors. The result can be written in factored or expand form. So that's just the beginning. Then we will have multi-level fractions, right? So according to that algorithm, let's do what can be done here. So here we have multiplication. What it says, convert any division to equivalent multiplication. We already have multiplication, right? So we're looking for common factors. So this disappears. Now 8 and 16. Right? So as a result of that manipulation, I have 2 over 5. Correct? gentlemen. B, 7 over 16 divided on 2. So we need to convert division to multiplication. What is do? I flip that fraction. So 7 over 16 divided on 2 over 1. Then I do 7 over 16 times 1 over 2. What I have, 7 over 32. Another option, but that's different algorithm. Okay, that's different from here. So if you follow that algorithm, we will go this way. Of course, you can skip, for example, this part, right? And do it manually. Okay, C, 15xy squared xy cubed times xy cubed 5x. Okay, to start with, let's open that brackets here. We already have multiplication, so now we can take what red pen and so 3, 1. Now x and x, y cubed and y cubed, x. Good. So do I still have fraction here? No. 3 times y squared times x squared. Well, if you like x go first, you can write that. Any questions? Okay, gentlemen. Perform operation and simplify. Let's do it. X squared minus 4x minus 12, 2x minus 12 times x minus 4, x squared plus 4x plus 4. So let's analyze. 12, it's a not perfect square, right? So 3 times 4 will give me, no, 1 times 12, no, 2 times 6, yes? So it will be minus 6 plus 2. So let's do that on the side. So x squared minus 6x plus 2x minus 12. And that is x minus 6 plus 2, x minus 6. And I have x minus 6, x plus 2. So we worked with that. Now, what about here? I can take 2 outside, right? This one, 4 is a perfect square. 2 times 2 is 4, so okay. We know what to do now. First fraction changes to x minus 6, x plus 2. 2 taking outside, x minus 6 times x minus 4. Here I have x plus 2 squared, right? Is it? Okay, now This disappears. This disappears. And what I have, and I have x minus 4, 2x plus 2. Any questions? Okay, let's do b. 4y squared minus 9, 2y squared divided y squared minus 2y minus 15, 4y squared plus 12y. So let's do this. Here we can what? Say that it is 2y squared. Okay, let's put it, let's do steps. 2y squared minus 3 squared. Good? 2y squared, just as is. Now we have to change division with multiplication. For that, we flip the fraction. So times, here, let's take 4y outside. And I have what? Y plus 3. Yes? Now, in this case, 15, it's not a perfect square. So if I work it on a side, let's do it here. So 5 times 3 will do, right? 5 minus 5 plus 3. So y squared minus 5y plus 3y minus 15. And that I take y outside, y minus 5. Here I take 3 outside, y minus 5. And I have what? Y minus 5, y plus 3. It means that this trinomial can be factored as that. So now I have multiplication. I can simplify. Well, not yet. Well, some of it, yes. What I can do, 2y squared and y, right? Now I can do this and that. Yes? Okay, what I have left? 2. Here I have 2y minus 3, 2y plus 3. And here I have y minus 5. That's it? Looks like it. So I would rather do this. 2 or 8 y squared minus 8, 18 over y. So I can come back and make it, right? And then times 2. Well, maybe yes, maybe no. This takes less space, let's put it this way. But on the other hand, this one is factored. Right? So it depends what I need. Okay, let's do the last one. So 2x minus 6, 1 minus x divided on x squared minus 2x minus 3, x squared minus 1. Okay, so what I have, First fraction, I can take 2 outside, x minus, 3. This one, I have 1 minus x, and I have x squared minus 1. So this one will expand, x minus 1, x plus 1, right? So I take minus outside, and I have this. Then division, I change for multiplication. X squared plus 1 jumps upstairs and expands like that. Factors like that, actually. This one, 3 is not perfect factor, but 1 times 3 will do the job. So I have x squared minus 3x plus x minus 3. What I have, x minus 3 plus x minus 3. And as a result, I have x minus 3, x plus 1. So x minus 3, x plus 1. Okay, so now I take my red pen. What I see, this and that cancels out. This and that cancels out. This and that cancels out. And I have 2 divided on minus 1, which is minus 2. Any questions, gentlemen? So main suggestion here, no rush. If needed, one baby step after another one. So don't lose any signs, be careful, and you'll be okay. Okay, try this too. Do it. Oh, you guys still working? Okay, do it. You done? So I worked with the first trinomial. That's how I factor it. Okay, let's analyze this trinomial. So that's the perfect square, which is 5 squared. If I take 5 times 2, I have minus 10. So I can change that fraction to x plus 5, x minus 2, over 5 outside, x minus 2, times x minus 5. And here is what? X minus 5 squared. Right? So I take my red pen, this and that cancels out, this and that cancels out, and as a result I have x plus 5, 5, x minus 5. Any questions? You have the same answer. Nice. So let's work with the second one. So what I see, this trinomial, let's start with the trinomial. 1 and 6, right? But not gonna work, right? Why? Because minus 1 times 6. Okay, so to stay on the safe side, let's what? What is it? What is this? Yeah, something happened. Okay, so where our okay. So what we're gonna do looks like it's not gonna expand, right? So x squared plus 5x plus 6. Let's double check that graph. Well, it does expand. Minus 3, minus 2, right? So you see, we need to be careful with that method. And what? Consider okay, so what we have here may form something is happening. Okay, so now minus 3 minus 2, right? Huh? Okay. Uh, x squared plus 5x plus 6. That's the graph. Minus 2 minus 3. Okay. So, suggestion, the simplified algorithm we chose, right? Maybe we come back and go over that algorithm, what was long and annoying, and see maybe there we find some, uh, but that's another way to calculate that, and that is this. We find D as the formula. You know that formula? So write this down. If you have trinomial and you want to find solutions, other words, factor it, we use that algorithm. So b squared, here I have this formula based on that notification, right? So b squared minus 4ac, what I have, b squared 25 minus 4 times 1 times 6. So 25 minus what? 24, it's 1, right? Yes? Kasra, do you know this method? Then x1, 2 is minus b plus minus square root from d over 2a. That's the second step. So x1 minus b, it's minus 5, minus square root of 1, 2a, a is 1, so 2. x2 minus 5 plus 1 over 2. And this trinomial can be written as x plus 3, x plus 2. So let's open it up. X squared plus 2x plus 3x plus 6. Good? Good. So come back to this. First fraction, 3 outside. Here, well, let's take minus outside. I don't know if I need it, yes or no, we'll see, right? Then division, I change for multiplication. Numerator, x minus 3. So I got a good feeling. Now the bottom is x plus 3, x plus 2. Now where's my red pen? This and that, this and that, this and that. And I have left with minus 3. Okay, so gentlemen, that's the one. Okay, universal one. Little longer, maybe yes, maybe no, but okay, when we don't have solutions, when d is less than 0, then we will not have any solutions, real solutions. Okay, let's take a break for what? Till I come back for 11, theoretically. So break. Let's continue. So I would say if that procedure, what we have here, doesn't work, you can always go to that green formulas what I showed you today and factor a trinomial and factor a trinomial. Now, complex rational expressions. Eric is here. So that's the multi-level fractions, right? That's what it is. What we do, we rewrite the complex rational expression as a division, then convert to equivalent multiplication, and then we do what we did before. Okay, let's try, let's see. So for A, the main fraction is this, 4xy, and it's divided on 2x over 5. So what I do, 4xy over 1 times, or actually divide on 2x over 5. Then I have 4xy times 5 over 2x. Any questions to manipulations I just did? When you have enough experience with that, what you're gonna do, you're gonna take this and jump right away to your numerator. Because 2x stays in denominator anyways. But first, I suggest that you go step by step before you get better experience. So this, and what I have. Do I have fraction? No, I don't. So 10y. That's what it is. Let's do B. So, yeah. I need it to be more horizontal than that. X squared minus y squared over 2x. X minus y over 3x squared. So what we do, we write numerator then we replace the fraction line with division. Then we replace division with multiplication. Now we're talking. So, well, simultaneously we could work out that as well, right? So that's the formula, x minus y, x plus y. Here I have 2x times 3x squared, x minus y. Let's put that in parentheses. So this and that, this and that. What I have, 3x, x plus y over 2. Or you can put like this, 3 over 2x, x plus y. It's the question of your taste. Yeah, too much. So, but you got an idea, right? Replace with fraction, then multiplication, and then, okay, try this too. Yes? And all of a sudden I don't have fraction anymore. The answer is for B. You have the same? The second one, so multi-level fractions. So let's do a few steps simultaneously. So if I analyze that trinomial here, what I see, the perfect square first element, the perfect square last element. So x and y, if I find double product, 2xy, that's what I find. So x plus y squared, that's the numerator from the top fraction. This music divided on 3x squared. Then I divide x plus y over 6x. Now what I do, I change division for multiplication. Let's put that into parentheses. So what I have, that and that simplifies. Now this and that simplifies. That and that. As a result of the game, I still have fraction, and this fraction is 2x plus y over x. That's it. Any questions? Okay, use multiplication and conjugates to rationalize a numerator or denominator of a fraction that has a binomial with irrational term. So let's read that guideline here. To use multiplication and conjugates to rationalize the numerator or denominator of the fraction that has a binomial with an irrational term. First, determine which part of the fraction, numerator or denominator, is to be cleared of a binomial with an irrational term. So first, you have to understand what you want to rationalize, right? Second, multiply by 1 in the form of n over n, where n is the conjugate of the binomial with the irrational term. Does everyone know what conjugate is? Okay, I will explain. Simplify the resulting expression. Let's say if I have a plus b, the conjugate will be a minus b. Why it's important? Because if I take a plus b times a minus b, what I have this. And if in case, let's say b is square root from 2, then what? By multiplying on conjugate, what I have? I get rid of square root, right? So let's see. Rationalize the denominator of the fraction. So what I see, minus here. What is the conjugate? 2 plus 5 square root of 2. Let me write this here. So I multiply. In order not to change fraction value, I need to multiply both numerator and denominator. Okay. At the bottom, oh, let me do steps here. Okay. Too fast. Agree? Oh, I need to do one more step. No? Everybody see that transformation? This times that. So that's what? Difference of two perfect squares. Not perfect in this time, but difference of two squares. Now what I have at the top? Okay, so let's open that, see what happens. 2 plus 5 square root of 2 plus 4 square root of 3 plus 10 square root of 6. Well, does it help me? Not really. So what I gonna do? I gonna keep parentheses there. I don't bother. It looks better, right? Now here, 5 squared, 25 square root times 2. So what I have, 50 minus 4, what is it? Minus what 21? What are you talking about? First you multiply 25 times 25 times 2, 50 minus 4 is 46. So as a result of the game you have minus. Oh, let's do, okay. Let's do steps. One plus, my God. 2 square root of 3, 2 plus 5 square root of 3 minus 46. Now we can live like that. Or we can take calculator and calculate. Or we can do this, let's say 1 over 46. And then you take 2 square root of 3. No. It would work if I had minus here, right? So I would flip that. So minus 1 plus 2 square root of 3. Again, that's just the game of if you need the value, take the calculator and with a certain accuracy you calculate. Any questions? So did you get how to use conjugate? Rationalize the numerator. So same fraction. The only I need to get rid, by the way, rationalize what I have. I have no square roots in my denominator. It's rational. That's why I did that, right? Now I need to have rational number into my numerator. So what I have to do? Conjugate will be 1 minus 2 square root of 3, and same value I have to, in order not to change the fraction, right? So 1 minus, let's put that 1 squared minus 2 square root of 3 squared. And here I have 2 minus 5 square root of 2. 1 minus 2 square root of 3. So 1 minus 4 times 3, 12. Minus 11. Now, if I analyze that, those two are negative numbers, so it's going to be negative. I don't bother. Right. So I can live like that. So the result of the manipulation is that I have rational value into my numerator. What happens in denominator, frankly, I don't care at that time. Any questions? Okay, try to do this, guys. Take a few moments, do it. Okay, so this one, I work with denominator, right? So what I do, I use conjugate for denominator. As a result, denominator is 3 squared minus 2 square root of 3 squared. And this one, 2 plus 3 square root of 2, 3 plus 2 square root of 3. So what I have, 9 minus 4 times 3, 12, right? So as a result, what I have, 3, oops, I have this. Yes? Right. Okay, this one, numerator. So I need to multiply on conjugate for the numerator, which is 2 minus 3 square root of 2. 2 minus 3 square root of 2. So numerator, 2 squared minus 3 square root of 2 squared. And here I have 3 minus 2 square root of 3, 2 minus 3 square root of 2. So 4 minus what I have, 9 times 2 is 18. Minus 14 Any questions? Good. So adding and subtracting rational expressions. Let's see what kind of beast is this. So this game about what? Common denominator, right? So let's play with that. Well, I have same denominator. What is it? 8. 3 plus 1. Now I can simplify, and that's what it is. So this one, b, 7 over 12 minus 1 over 3. What is the least common denominator? 12. So 7 it is, 7. Here, to make it 12, what I should do? Times 4, right? Good. C, 5 minus 2 over 3. So common denominator is 3. But this one not so easy. So 4 and what? 1 over 3, right? Agree? Now let's do D. 5 over 2x plus 3 over x plus 9 over 4. So what is the common? 4x, right? So 2 here, it means 10, plus 4 here, which is 12, plus x here, which is 9x. So what I have, 9x plus 22 over 4x. Good, gentlemen. Any questions? Oops. Try this, please. So what is the common here? 9, right? 5 plus 6. What is it? 11 over 9. Well, if you want to what? Mixed number, it will be 1 and what? 2 over 9, right? 2 or 3? 2. Good? Now the second one. I can play with with fractions like I did here, but what I can say? I can say I have 6 full units of something and I take away 4/5 of 1 unit. So what I'm left with, 5 full units and 1/5. Yes, guys, we good? Well, in case you want to play, 6 times 5 is 30, minus 4 over 5, where I have 26 over 5. And that will be 5 and 1 over 5. It's the same thing. Or you can just use the logic and say I have 6 units minus portion. That's what it is, 3. So common denominator here is 3x, right? The first one, 9 plus 2 plus 5x. Result is 5x plus 11 over 3x. Hope you got the same answers. Did you? So to add or subtract rational expressions with unlike denominators. First, find the least common denominator, LCD. Change each fraction to an equivalent fraction with the least common denominator. Add or subtract numerators. Keep the same common denominator. Reduce or simplify as possible. That's just summary for what we did above, right? Okay, so let's have more complicated. So this case, that's my denominator. Yes or yes? So the first fraction I have to multiply on x minus 3. Sign is the same what I had here, which is plus 3x plus 3. So what I can do, I can open brackets at the top. X plus 3, x minus 3, what I have? 4x minus 12 plus 3x plus 9. 4 plus 3 is 7x minus what? 3. X plus 3. And here, what I have? I have lovely formula, right? Which is x squared minus 9. Yes, gentlemen? Okay, let's see what I can do here. X plus 5, x minus 5. And yeah, that's the lovely formula again. Oops. That's the lovely formula again. We make it more horizontal. So here, 2x minus 5 plus 3 x plus 5. So x squared minus 25. Here I have 2x minus 10 plus 3x plus 15. X squared minus 25, and as a result 5x minus plus 5. Well, I can do this, for example, 5x plus 1, x squared minus 25. Or I can live like that. Subtract. So x minus 2 x plus 4, x plus 4 minus 5, x minus 2. Any question about that step, what I just did? Jen, you okay? Okay? So at the bottom, nothing. Just it is what it is. At the top, x squared plus 4x minus 5x plus 10. X minus 2, x plus 4. Now what I have here, x squared minus x plus 10. Okay, let's play this manipulation. By the way, I mentioned before, if that manipulation with multipliers of 10, 1 times 10, right? If it doesn't work, so use that denominator approach, right? So what I have, 9 and 1, right? So x squared minus, what is it? No, 10 and 1. Hold on a second. No, it's not going to work like that. 10 and 1 doesn't work. 2 and 5 doesn't work. What works? That's it. I don't have any other multipliers. Okay, in this case, let's recall that formula. Let's see what happens. So D is b squared minus 4ac. So b squared, that's 1, minus, what is it? 4 times 1 times 10, and it's minus 39. Yes? So less than 0, no real roots. Let's double check. X squared minus x plus 10. So what I see that graph doesn't cross x-axis, so I don't have roots. And what does that mean? It means that I cannot factor it. And it looks like that's the final answer. Okay, let's do this one. So I say that's the prime trinomial, prime polynomial. This one, 2x, x minus 2, minus 7, x plus 6, x plus 6, x minus 2. So we okay with that step, guys? Good. So let's open brackets here. So what I have, 2x squared minus 4x minus 7x minus, what is it, 42, right? X plus 6, x minus 2. X plus 6, x minus 2. Now, 2x squared minus 11x minus 42. Okay, let's try that. Well, let's save time and see here. So 2x squared minus 11x minus 42. Yeah, I have some irrational values. Some irrational values, so let's do that. Let's then take D. So B squared minus 4 is C. 11 squared is 121 minus 4 times 2 times minus 42. I can take my calculator. So 121 minus 4 times 2 times minus 42. 457. Well, that's what it is. 457. Let's put it this way. If I factor the top, I'm not going to reduce the bottom, right? So I probably wouldn't continue because it will bring me nothing. No benefits. So I just leave it like that. When I say benefits, I'm talking about simplicity of the expression I have. If I had perfect square root here, it would be a different story. Okay, addition or subtraction of fractional expression to simplify complex fractions. So use addition or subtraction to combine terms in the numerator or denominator so that each contains a single fraction. Rewrite the complex expression as multiplication of the reciprocal of the denominator. Proceed using the procedure for multiplying rational expressions. So let's see. So what I have, 1 plus 1 over x, 2 over 3. First thing, I need to what? Find common denominator here, which is x plus 1. Yes? 2 over 3. Now what we did, x plus 1 over x, we change for multiplication, which is reciprocal, or 1 over. In other words, simple language, we flip that fraction, right? And I have, well, if you wish, I can write this one, and that would be the answer. Okay? Let's see B. 2 over x minus 5 over 2x, 3 over 4x plus 3 over x. Okay, for now, we keep a big fraction. Okay, let's do it. What I have, 2x here. So 4 minus 5, that's it. Yes? Yes. What I have, 4x here, 3 plus 12. So 4 minus 5, I have fraction minus 1 over 2x times 4x over, what is it? 15. Yes? Looks like it. What can be simplified here? Where's my red pen? And I have minus 2 over 15. Agree? Let me see how many more I have. Oh, just one. Okay. Okay, let's save some. You want to do it, guys? Yeah, take a minute. Do it. Okay, so let's do it. This one. So x, 2x plus 3, 1 over 4. Now, 2x plus 3 over x times 4 over 1. Well, let's multiply, or we can live like that. I think that's fine, right? Huh? Sorry? Yeah, you can do that. Or you can have factor. No, of course not. That's what it is. You cannot reduce the x's because there is no common x for two terms here. You cannot factor. So this one, what I have here, 3x, 9 minus 4. Here I have 6x, 1 minus, what is it, 12, right? So 9 minus 4 is 5 times 6x. Here is minus 11. Where's my red pen? Minus 10 over 11. Okay, gentlemen, you have no questions. On this happy note, we're done for today, and I believe that our presentation is online, and practice exercises are online as well. So thank you for coming, and see you Wednesday.